no matter where you look. A beehive, a piece of volcanic rock, a molecule, even a giant storm on Saturn. They all share the exact same shape. Why? The universe could have picked triangles, or squares, or circles, but over and over again, it chooses hexagons. 15 images, one shared secret, a honeycomb, soap bubbles, graphene, basalt columns, Saturn's pole, snowflakes, cooling lava, crystals, a turtle's shell, an insect's compound eye, quartz. You still can't quite see the pattern yet, but it's there. Every single one of them is hiding a hexagon. Coincidence? Before we go further, try this yourself. Grab any shape and try to tile a flat floor with it. No gaps, no overlaps. Circles fail immediately. Pentagons fail too. Mathematically, only 3 regular shapes can do it perfectly. Triangles, squares, and hexagons. So the real question isn't why hexagons can tile space. It's why, out of those 3 winners, nature almost always picks this one. Keep that number 3 in your head. It matters later. Let's start with the bees. Most people assume the same thing. Bees build hexagons because they are clever. That's not quite it. Scientists actually tested this, comparing wax cells shape by shape. Bees that build hexagons use less wax. Same amount of wax, more honey stored. Compare it to squares, and hexagons still win. Compare it to triangles, hexagons win again. Out of every shape that tiles perfectly, no other one does it better. Wax is expensive to make. A bee burns huge amounts of honey just to produce it. So we have our first idea. The universe is trying to save something. Now look at bubbles. A single soap bubble is always a perfect sphere. That's the shape that holds the most air with the least surface. But when a lot of bubbles crowd together, they don't stay circles. Circles leave gaps between them. Each gap is wasted surface, wasted energy. So the walls between the bubbles flatten out and bend until they become hexagons. Not because they want to, because it's the shape that wastes the least energy for that layout. A mathematician even proved this formally. It's called the honeycomb conjecture. But then, why does this happen with solid rock too? Basalt. This is solid volcanic rock, not soap, not wax. When a thick lava flow cools down, it contracts the same way drying mud contracts. Cracks start to form to release that stress. Those cracks are trying to spread the tension as evenly as possible. And the shape that does that best, using the fewest cracks, is almost always the hexagon. The Giant's Causeway in Northern Ireland, Devil's Postpile in California, Fingal's Cave in Scotland. Thousands of stone columns, each one nearly a perfect hexagon. And this still isn't the strangest part. Saturn. This is its famous hexagon, discovered by the Voyager probes in the 1980s. It sits right on top of the North Pole. How can a hexagon, 18,000 miles wide, even exist? This isn't solid. It's a raging storm made entirely of gas. It's a pattern that forms inside a fast-moving jet stream. Scientists have recreated a similar effect with spinning fluids in a lab. And even today, we don't fully understand every detail of it. But there's an even bigger question left. Graphene. Pure carbon, just one atom thick. Every single atom locks into a hexagon with its 6 neighbors. It's one of the strongest materials ever discovered. Stronger than steel, at a fraction of the weight. The hexagon spreads force evenly across the whole sheet. No other simple grid does it as efficiently. One more clue and it's tiny. A single snowflake. It comes down to the water molecule itself. The angle between its hydrogen atoms naturally favors six-fold symmetry. So when water freezes, molecule by molecule, it locks into that same six-sided pattern every time. Zoom out from a single molecule to an entire storm, and the answer barely changes. Now put it all together. Bees, bubbles, crystals, lava, atoms, Saturn. None of them are connected. None of them copy each other. None of them evolve together. A bee has never seen a basalt column. A carbon atom has never seen Saturn. They simply share one goal: waste less material. Fill all the space with no gaps left behind. Spread the force as evenly as possible. And out of every shape available, only one keeps satisfying all three conditions at once. And every single time, the math arrives at the exact same answer. The universe doesn't know what a hexagon is. It doesn't think. It doesn't choose. It doesn't even remember what it built somewhere else. But over and over again, in completely unrelated corners of reality, the math leads it to the exact same place. Maybe nature doesn't draw hexagons. Maybe it simply hasn't found anything better. And once you notice it here, you start noticing it everywhere else too. Here's the part most people never hear about. Engineers notice this pattern too. Look inside an airplane wing. Hidden underneath the metal skin, there's a honeycomb structure. It's incredibly light and incredibly strong. The same design sits inside satellites, inside crash-absorbing car panels, even inside some running shoes. We didn't invent this trick. We just finally noticed the one nature had already been using for millions of years. So here's a question for the comments. If a beehive, a bubble, and a whole planet all agree on the same shape, what else has nature already solved that we just haven't noticed yet? Drop your best guess below. If this kind of hidden pattern is your thing, hit subscribe. We go looking for the turning points behind science that most people never notice. Like equals this reaches someone else. Turning point.